Okay, so today we're going to do double factoring, and that just means you need to factor twice. So we're going to have our tip in the corner here. So we're going to have GCF first, trinomial second. Okay, so I guess I could put that in a different color. It's going to be purple. Okay, so we always want to start with a GCF. That should be the first step of factoring always. So if we look here, the first thing is we look for a greatest common factor between here. So we can see that they're all divisible by 2. So our greatest common factor is going to be 2. So we have 2, and then we're left with b squared minus 6b minus 40. And then we do our normal factoring. So a trinomial, right now we have a trinomial left. So we're going to do our normal factoring. So we need two numbers that multiply to a times b and add to -6. So that's going to be -10 and 4. So here we have 2, b minus 10, b plus 4. And that's it. The last thing that you want to do is check. So if I FOIL this, I get b squared plus 4b minus 10b minus 40. And then we still have that 2 on the outside. And then we combine like terms. The 4b and the minus 10b, and then we multiply out the 2. So we're sort of working backwards to check. 2b squared minus 12b minus 80. So we can see it's the same, so we did it correctly. So our final answer is right here. This is factored form. So factored form is going to have your greatest common factor on the outside, and then your factors in parentheses. If it was just an x, then the x would also be on the outside. All right. This is factor form. Factor form GCF on the outside. Okay. So let's look at this next problem. So we're going to give you another tip in red. Tip. Whenever the greatest degree, whenever the let's say coefficient in front of the greatest degree is negative, factor out a -1. Or a negative number. Okay. A little messy. Trying to add a marker so you could see. Okay, so a lot of vocab in this sentence, right? Whenever the greatest degree, so here our greatest degree is 2. So whenever the number in front of it, the coefficient in front of it is negative, you want to factor out a negative number. So what does that look like? We have our greatest common factors. So all these are divisible by 4, but we want to pull out -4 instead. So if we pull out -4, we're left with g squared minus 3g, because we're dividing a positive number by a negative number. So we're left with a negative number. And then 112, you can use your calculator, or you could think, okay, 100 divided by 4 is 25, and 12 divided by 4 is 3, so it's 25 plus 3, 28. So this one was our greatest common factor, our -4, and now we have our trinomial. So we need two numbers that multiply to negative 28 and add to negative 3, which is going to be negative 7 and 4. So we have negative 4g minus 7g plus 4. And notice I'm not doing anything fancy for these two examples, like the reducing after the Australian method or factoring by grouping, because the a term is just 1, right? Once we took out the greatest common factor, this a term goes to 1. And so just to be clear, right, standard form of a quadratic is ax squared plus bx plus c, right? So when a is 1, then the factoring is really easy. You don't have to do grouping. You can just find the numbers that multiply to what you're looking for and add to what you're looking for and just put them next to the factors. So whenever a is equal to 1, life is going to be easier. And then we can always double check again. So we have negative 4g squared plus 4g minus 7g minus 28. We have negative 4g squared minus 3g minus 28. And then we get negative 4g squared plus 12g plus 112. So when we multiply it back out, we can see that we did it correctly. And so you can always check and see if you got it right. Okay, let's look at the next example. So this one is a little bit bigger numbers, but it's still the same steps. So we're going to start with our greatest common factor. So if we look here, this is divisible by 3, 10, 6, and 5. Or wait, we could look at the 18 because 18 is the smallest. So we're supposed to look at the smallest one. This one's 1, 18, 2, 9, 3, and 6. So if we can see here, this one's divisible by 6, but this one isn't. So we have to do 3. So 3 is a number that is our greatest common factor. And then we have our k's. So this one can have 5k's, 4k's, and 3k's. So we're going to pull out 3k's because that's the most that this last guy can give. Okay, so if we have our greatest common factor as 3k to the third, then what's left here is going to be 10k squared plus 19k minus 6.
I thought this would be rocket science.
What?
And I thought this would be rocket science.
Oh, no, it's not so bad. Okay, so we need to find two numbers that multiply to negative 60. And add to 19. So, okay, actually, sorry, I think there's an error. So I'm going to make this a plus right here, because the other one's not factorable in a nice way. Okay, typo on the paper, sorry. So it's trying to add or multiply to positive 60 and add to 19. So that's going to be 15 and 4. So now we're going to do factoring. I'm going to do factoring by the Australian method, and then I'll show you factoring by grouping. Okay, so we still have that 3k to the third on the outside. You always can't forget your greatest common factor, but you can just like ignore it and then come back to it. So we have our two factors. We always start with 10k because this is a 10, and then we have it always over 10. So that's how we set it up. And then we take our two factors, so we have our 15 and a 4, so plus 15. See if I can put this in a different color. Right? Plus 15 plus 4. Right? And our 10 comes from here, the 10. Okay, so now we have to simplify. So some of you are asking me some questions about the simplification. You're pretty much just taking more greatest common factors from the top two, right? So we have 3k3. So if we look here, the greatest common factor is 5, right? So we're going to pull out a 5. We're left with 2k plus 3. And then here we have another greatest common factor of 2. So we're going to pull out a 2. And then we're left with 5k plus 2 all over 10. So to go from this step to this step, we pulled out 2 greatest common factors. Again, right? So much greatest common factor. We pull them out from this guy here, and we pull it out for this guy here. And now we can simplify. So if we see here, this 5 and this 2 multiply out to 10, and that's how we get rid of the 10 on the bottom. So we have 3k to the third times 10, 2k plus 3, 5k plus 2. So this 10 right here was from these two. And then the whole thing is over 10. If you wanted to, you could make it 30, but I'm just making it 10 because we know in the end we have to cancel out with this 10 in the bottom, right? So now these 10s cancel, and we're just left with not that much room. Gonna put it over here. 3k to the third, 2k plus 3, 5k plus 2. So this is our answer. And we can always double check and factor it back, or multiply it back out to see if we get the same thing. So if we do 3k to the third, 10k squared, plus 4k, plus 15k, plus 6, I just FOILed or double distributed. We're going to combine like terms. And then we're going to distribute 30k to the fifth plus 19 times 3 is 57. You can use a calculator. Oh, here I use x's and here I use k's. They're all k's. K to the fourth plus 18k to the third. So we know that we did it right. So this one we used Australian method. I'll use grouping by, or factor by grouping in a different problem. So again, factoring is just a lot of taking out the greatest common factor and then simplifying. Okay, this one's a little trickier, but it's not that bad. Okay, so when you see this, a lot of people, the first thing they'll do is they'll divide both sides by 6, and then they'll try and figure it out from there. So I want to be very clear, right? Okay. When you see a problem with degree greater than 1, you probably will factor. Probably factor. Right? So here we see this is a degree 2 term. This is a degree 1 term. Since this degree is greater than 1, you're probably going to factor. So please don't try to take the square root. Don't try to divide by 6 first. Like, the thing that you want to do is factor. And if you remember from the last thing, the first step in factoring, when it's like this, is bringing it all to one side. Right? So the first thing that we want to do is we want to bring everything to the same side. So we have 6b squared plus 48b equals 0. Same side and set equal to 0. Okay, so this one, it looks weird because there's not 3 terms. It's not a trinomial. But we actually did this way back when. We did this like 2 lessons ago, 3. So this one we just got to take our greatest common factor. So we have a 6 that can be taken from both, and then a b. So we have 6b. So this is our greatest common factor step. This is like a pre-step, right? 0, 1. So we're left with b plus 8 equals 0. So we took our greatest common factor. We don't need to do a trinomial because all that's left is it's already in factored form. So this is greatest common factor. And now we just need to do the zero product property. So we have 6b equals 0 and 6 plus 8 equals 0. So this is b equals 0 and b equals negative 8. And those are our two solutions. And let's check it in our calculator just to prove to you. So one of ours is 0. So we have 6 times 0 squared, which is 0. And we have negative 48 times 0, which is 0. So 0 works. And then let's try negative 8. So we have 6 times negative 8 squared, which is 384. And then we have negative 48 times negative 8, 384. So both of our answers worked, and that's how we can always check it with the calculator. You go back to the original problem, and you put both of those answers in. All right. We're almost done. 2 more problems. Okay. Again, remember the tip I just told you. When you see a problem with degree greater than 1, you will probably factor. Okay, so here we have a degree 3, degree 2, degree 1, degree 1. We are probably going to factor, so let's get everything over to the same side. Right? So step 0, we're going to add r to both sides. So we have 45r to the third plus 51r squared. Negative 13 plus 1 is negative 12r equals 0. And now we need our greatest common factor. So this one is 12 and 1, but these two can't do 12. And then we have 2 and 6. This one can't do 2. And then we have 3 and 4. So it looks like 3. 3 is going to be our greatest common factor. So we have 3, and then they all have an r. So r. And then we're left with 15r squared. 51 divided by 3, don't know off the top of my head. 51 divided by 3 is 17. Plus 17r minus 4 equals 0. So we took out the greatest common factor. Now we're going to do the trinomial. And this example I'm going to do grouping. But you could also do Australian if you like Australian. Okay, so we still keep the greatest common factor on the outside there. We're trying to find two numbers that multiply to negative 60 and add to 17. So that's going to be 20 and negative 3. So we're going to write this 15r squared. We're going to change this middle term here to the two numbers that we found. All right, so plus 20r minus 3r minus 4 equals 0. So I just broke this down into our two numbers that we found, our magic numbers, our key numbers. And now I'm going to do more greatest common factor. So I'm going to take this pair right here and find the greatest common factor. And I'm going to take this pair right here and find the greatest common factor. So when you do this factoring, it's a lot of organization. You can't lose anything, right? It's really easy to forget about this 3r, but we have to keep it off to the side here, right? And the greatest common factor here is 5r. So we're going to just do another big parentheses, 5r, and then another parentheses. We have 3r plus 4, right? So all this looks super messy, but this is the same thing. These two are the same thing. We just took out the greatest common factor of 5r. And then here, we want this 3r plus 4 to match, so we're going to take out a 1. Negative 1 as our greatest common factor. Because remember, when we have the tip up here, right? Whenever the coefficient in front of the greatest degree is negative, factor out a negative. So here, we have a negative 3. We want to factor out the negative 1. We're left with 3r plus 4 equals 0. So because we took even more greatest common factors, we have this other set of parentheses. But if you see here, this green right here matches that green. This red matches that red. Again, sorry if you're colorblind on all my videos. So this is equivalent to this. We just pulled out greatest common factors. Okay, almost done. Lots of steps in these. We still have our 3R. We pull out this pair right here, the 5R minus 1. We have our common factor right here, the common pair that we were looking for grouping. We're grouping like things together, right? This is the same as this, so we group it together. These two are on the outside, so we group them together, equals 0. So we finally have it in factored form. Finally, factors. Right, we have a greatest common factor in front. We have one of the factors in parentheses, and we have the third factor in parentheses. And now we finally have to solve, right? Solve. Okay, so we set this equal to 0. We're doing the zero product property, which is a vocab word. So we have 3R equals 0, 5R minus 1 equals 0, and 3R plus 4 equals 0. This one is easy. This is just R equals 0. This one we got to add 1 to both sides. 5R equals 1, and then divide by 5. R equals 1/2, or 1/5. Didn't write what I said. And then here, we minus 4 from both sides. 3R equals -4. R equals -4 over 3. So those are our 3 answers. And something else that I want to be very, very clear of is when you're degree 3, you can have up to 3 answers, right? So if we look at our other problems, right? This was degree 2, and we had 2 answers. Well, we weren't asked to solve it, but if we were asked to solve it, we'd have 2. Right here, we had degree 5, so we could have up to 5 answers. Here, we were degree 2, so we could have up to 2 answers, so we had the 2 answers. Okay, so last thing that we want to do is we want to check this with our calculator. So we have 0, that's one easy, 45 times 0. Actually, let me show you another way to check it. So I'm going to put the whole thing in an equation. 45x to the power of 3 plus 51x to the power of 2 minus 12x. So I sort of did put in the thing where they're all equal to 0. And I'm going to look at the table. Actually, I need to change this to independent ask. So I'm looking at the table, and I'm going to plug in my 3 answers to see if it equals 0. So we have 0 equals 0, 1/5 equals 0, and -4 over 3 equals 0. So that's a really quick way on a calculator to see if your answers work. But you could also do the old method, right? Like I could do 45, -4 divided by 3 to the power of 3, plus 51, -4 divided by 3 to the power of 2, minus 13, -4 divided by 3, making careful of all your parentheses. That's equal to 1.3333. And then if I do -4 over 3, it's the same thing. So you always want to check with your calculator to make sure. All right, this next one you can try. Pause the video and then double check. Okay, hopefully you tried it and we can check. Okay, so it doesn't really say what to do, but we're going to solve it. So we have our degree 2. We need our greatest common factor. Remember, when it's negative in front, we want to pull out a negative number. So all these numbers are divisible by 12, I think. Let's check 76. No, it's not. Okay. Okay, so we could do 76 divided by 4. There we go. So they're all divisible by 4. We're going to pull out a -4. We're left with positive 6b squared, positive 19b, positive 3. All right, so we pulled out a negative. We're left with all positives. We're going to set that equal to 0. I'm going to do the Australian method. So we need 2 numbers that multiply to 18, add to 19. So it's going to be 18 and 1. So we have -4, 6b plus 18, 6b plus 1, all over 6. Here's our greatest common factor that we need to take out. So we have -4, and do this in a different color, times 6 b plus 3. And then this, you can't take out a greatest common factor, all over 6. We can see that this 6 cancels out, so we're left with negative 4, b plus 3, 6b plus 1 equals 0. We're going to do our zero product property. So this one we don't need to set to 0 because there's no like b there. There's no variable there. It's just a greatest common factor. So we have b plus 3 equals 0, 6b plus 1 equals 0, and then we have b equals negative 3, b equals negative 1/6. And let's just check that with the calculator. So we have negative 24, negative 3 to the power of 2, minus 76 times negative 3, minus 12 equals 0. And then negative 24, negative 1 over 6 squared, minus 76, negative 1 over 6, minus 12, also 0. So we know that we did it. We checked. And that's it. So double factoring is not that bad. It's just taking a greatest common factor first and then making sure you're good at factoring. So lots of factoring from here on out. You want to be comfortable with it. Figure out the method that works for you. And if you don't like either or you're having trouble, definitely come to ACLab, ask me questions, come to study hall, email me.